Good morning, sir. Myself, Monica. I am from ECA second year. My bearing pin number 244G580407. My topic name construction of root locus in control systems. Subject code 23404. Introduction of root locus. The root locus technique is a graphical method used in control system design. It helps in analyzing the changes in roots of a characteristic equation as the system's gain varies. This method provides insights into system stability and transition response. This root locus is used for the system stability and transition response to find the system stability and transition response. Rules of construction of root locus. The first step is identifying the poles and zeros. Plot the open loop poles x and zeros. The poles are indicated with x, the zeros are indicated with zeros of the transfer function g of s into h of s in the complex s plane. Number of branches. The number of branches of the root locus is equal to the number of open loop poles. Second step, determine the root locus on the real axis. Root locus exists on the portion of the real axis where the total number of zeros and poles to the right of the portion is odd. Example, if you have a pole at -1 and -3 and a 0 at -2, the root locus will exist between -1 and -3 and the left of the -3. Third step, determine the asymptotes. The number of asymptotes is equals to the number of poles minus the number of zeros. The number of poles is indicated with n. The number of zeros indicated with m. Asymptotes angle. The angle of the asymptotes is given by 2k plus 1 into 180 degrees or n minus 1, where the k is equals to 0, 1, 2, continuous n minus m minus 1. Now, centroid. The point where the asymptotes intersect is called centroid and calculated as sum of poles minus sum of zeros. We all know that sum of poles are indicated with n, zeros are indicated with m. Sum of poles minus sum of zeros equals to the n minus m. Next step, find the breakaway or break-in points. If there are root locus branch between two poles or two zeros on the real axis, where will be the breakaway or break-in points between them? Finding the points. Solve the equation dk divided by ds equals to 0, where k is the gain and s is the complex variable to find the breakaway or break-in point. By this formula, we find out the breakaway and break-in points. Next step, determine the angle of departure or angle of arrival. If the root locus branch originates or terminates at the complex poles or zeros, the angle of departure or angle of arrival can be calculated using the angle of vector from the poles or zeros to the point of the root locus. The formula to determine the angle of departure or angle of arrival is the angle of departure or angle of arrival is the sum of angles of the vector pointing to the poles or zeros from all other points and zeros minus 180. Next step, finding the imaginary axis crossing. Using the Routh-Hurwitz stability criteria to determine the values of k for which the root locus crosses the imaginary axis. Procedure, substitute s is equals to j omega in the characteristic equation. We get imaginary axis crossing point. That is, equation is 1 plus g into g of s into h of s is equals to 0. By this equation, to find the imaginary crossing point and solve omega is equals to k. Next step, sketch the root locus. Symmetry. The root locus is symmetric with respect to the real axis, start and end. The root locus start at the open loop poles and end the open loop zeros are infinity. Whenever root locus starts at the open loop poles, then it will be end with only open loop zeros are infinity. Connect the points. Sketch the root locus branches by connecting the points determining in the previous step. By this diagram, we know about that angle of departure and angle of arrival. By this centroid and asymptotes, by this diagram we will clearly understand. Conclusion and applications. The root locus technique is the powerful tool for analyzing system stability and designing controllers. It aids engineers in understanding how changes in gain effect system dynamics. Mastering root locus construct enhance the ability to design effective and reliable control system. Thank you.